Okay, after Poisson distribution, let us take one more distribution, that is normal distribution. Now the formula that is to be used in normal distribution is x minus mu upon standard deviation, where mu stands for mean value. Remember, mu stands for mean value. This symbol, you know it, it is indicating standard deviation, and x is a normal variable. So first of all, take down the formula which is to be used in calculating probability for normal distribution. That is, z is equal to x minus mu whole divided by standard deviation, where mu stands for mean value, this symbol stands for standard deviation, and x stands for normal variable. Now mean and standard deviation, they are going to remain same in a particular problem. In all the different parts of the particular problem, this x is going to change. This is a random variable, it's a normal variable which will assume different values in different parts of a particular problem. So let us take a problem, right? The problem is in a management workshop. Please take it down, and all those who are having the handouts, you can always look up to illustration number 23 in normal distribution. So in a management workshop, to improve the skills of students, of a management institute in Jaipur, comma, the mean time spent on the program, is 500 hours, with a standard deviation of 100 hours. With a standard deviation of 100 hours. Now in this question there are different parts. We'll discuss the first part. The first part says that calculate the probability that a student will take between 500 and 650 hours to complete the program. 500 and 650 hours to complete the program. Right? Okay. Now the first part says that you have to find the probability that a student will take between 500 and 650 hours to complete the program. This is the first one. How we'll have to solve it? First of all, just pay attention to understand the different constants, the different terms which are used in this question. First of all, the mean value. Now look at the first line. The mean time spent on the program is 500 hours. So the value of mu is equal to 500 over here in this particular problem. Standard deviation, further after it has been clearly specified that the standard deviation is equal to 100 hours. So the value of standard deviation is 100 over here. Now we move on to the first part. The first part says that you have to calculate the probability that a student will take between 500. Now that's the mean value, 500. Explained to you earlier, the mean value in this question is 500, and the value of x, the other variable, the other value will be assumed by x. So x will be equal to 650. Now we start. Whenever a question comes, as far as normal distribution is concerned, you'll have to draw this normal distribution curve. It says that the central value is always the mean value. Remember, the central value will always be equal to the mean value, that is 500 over here. And the area on both sides of the mean value is always equal to 50%. The left hand side area is 50% represented by 0.50, and the right hand side area is also 50% represented by 0.50. Adding up both the areas will give you the total as 100% or simply 1. So the area on both sides of the mean value is always equal to 50%, which is rewritten as 0.50. Now it's a bell-shaped curve which remains open from both sides. Now in this question it has been asked to calculate the value of probability between 500 and 650. Now 650, where will it lie? On the right hand side of the curve or on the left hand side of the curve? Obviously on the right hand side of the curve. So somewhere after 500 you will have to mark approximately 650, after 500 on the right hand side curve. Now you will have to shade the particular area to represent the probability. The probability that a student will take between 500 and 650 hours to complete the program. Now you will have to apply the main formula, which is x minus mu upon standard deviation. The value of x is 650 minus mean. It will always remain 500 in this particular problem, and the value of standard deviation is 100. Now 650 minus 500 upon 100, that will be equal to 150 upon 100, or in simple words equals to 1.50. Now please take out your normal distribution curve which is attached, normal distribution table which is attached at the end of your handouts. On this table you will have to look for the values. They are increasing, as you are moving down. You will have to look in front of 1.5, and there are different set of columns till 0.09. Now since there is nothing after 1.5, so you will have to look in front of 1.5 and below 0, and tell me what is the value which is in front of 1.5 and below 0. 0.4332. Now that will be our final answer. How you will have to represent it? Please take it down. First of all, take down these particular set of calculations. That's 650 minus 500 upon 100. That is 150 upon 100 equals to 1.5. Now further, write it down after it. The table value of Z, the table value of Z at 1.5 is 0.4332. 0.4332, which we have just observed in this particular table. Full stop. Thus we can conclude that the probability that a student will take between 500 and 650 hours, to complete the program, is 0.4332 or 43.32%. If you want to express it in percentage, you can always express it. Multiply the value by 100, you will get the answer in percentage. So it will be equal to 43.32%. That will be the final value, the probability that a student will take between 500 and 650 hours to complete the program. Now take down the second illustration, second problem in this particular question. The problem has not ended. This is the second part. Please take it down. Find the probability. Find the probability that a student will take. That a student will take more than 700 hours. More than 700 hours to complete the program. More than 700 hours to complete the program. Now let us discuss the second part. It's entirely different from the first part. It says that you have to find out the probability that a student will take more than 700 hours to complete the program. Now see, you will have to draw a curve. In this curve, the central value will again remain same, that is 500. Now 700, obviously it will also lie on the right hand side of this mean value. So mark it approximately on the right hand side of this particular mean value. Now it has been asked in this question to calculate the probability of more than 700. So where will it lie? More than 700 will be this particular area. Now more than 700. Initially we will have to apply the same formula, that is x minus mu upon standard deviation. Now you know that mu will remain same, that is 500, explained to you earlier, and the standard deviation will also remain same, that is 100. Then what will change? The value of x. In the first part the value of x was 650. Now in the next part the value of x will be 700. So please solve it. 700 minus 500, that is 200 upon 100 will be equal to 2. Now take out your tables and please see what are the values that you are getting. In your tables, you look it in front of 2, and since nothing is specified after 2, so you will have to look again, just below 0 column. What is the value?
0.4772.
0.4772. Now please pay attention because this is very crucial. This probability is the probability between 700 and 500, but that we don't have to calculate. In this question the individual is asking about the probability of more than 700, but with the help of formula we can always calculate between 700 and 500. Now you know the value of probability which is lying between 500 to 700 is 0.4772, and you know that the total area on this particular side is 50%, that is 0.50. So what will be the value of this remaining area? That is 0.50 minus 0.4772. Please solve it to find out the value of probability. 0.0228. So that's the value, that's the final answer. It is equal to 0.0228. Now how will this be represented? Please take it down. Please write down the table value of 2. The table value of 2 is 0.4772. Is 0.4772. Full stop. Thus we can conclude that the probability that a student will take more than 700 hours to complete the program is 0.5 minus 0.4772. 0.5 minus 0.4772 is equal to 0.0228. Is equal to 0.0228. Right? Now take down the third part. The third part, find the probability that a student will take between 550 and 650 hours to complete the program. find the probability that a student will take between 550 and 650 hours to complete the program. Now see, we move on to the third part. Now this is again different from both first as well as second. The third part says that you have to find out the probability that a student will take between 550 and 650 hours to complete the program. Now we'll have to draw the curve again. You know that the central value will always be the mean value. That's 500 over here. Now 550, it will lie on the right hand side of this mean value 500. 650 will obviously lie further. That will be the value of 650. Now in this problem, it has been asked to calculate the probability between 550 and 650. So what area will be shaded? Obviously you cannot shade between 500 and 550. You have to shade the area between 550 and 650. Now what is the modus operandi to solve this problem? Firstly, we will calculate the probability between 650 and 500, right? That is the first phase. Then next, between 550 and 500, and from the bigger area, we'll have to subtract the smaller area to get the resultant value. See how you will get it. First phase. The formula remains same, x minus mu upon standard deviation. Now x will be 650 minus mean will always be 500 upon 100. Now 650 minus 500 upon 100, that will be equal to 1.5. Now see the table value of 1.5, that will be equal to 0.4332. So the bigger probability turns out to be 0.4332. Now the second phase. The formula remains the same, x minus mu upon standard deviation. How will this be solved? Please see 550. That's the another value of x. Both these are representing x only. So 550 minus 500 upon 100. So 550 minus 500 upon 100. That's 50 upon 100 equals to 0.50. Now please look into your tables and tell me what is the value of 0.5. That's equal to 0.1915. Now the probability between 550 and 500 will be equal to 0.1915. Now you subtract 0.4332 minus 0.1915. That will give you the final answer, that is 0.2417. That will be the final answer of this particular problem. So remember, initially we had to solve for 650 and 500. Then between 550 and 500. So from the bigger area, you will have to subtract this smaller area to get the value of the next area, that is 0.2417. Is it clear? Next, take down the fourth part. Please take down part number 4. Find the probability that a student will take between 420 and 570 hours. Find the probability that a student will take between 420 and 570 hours to complete the program. Now that's again very important, between 420 and 570 hours to complete the program. See, first of all, we will have to shade the area. The central value will always be 500. Now 420, it is just before 500 on the left side of the curve, and 570 will be on the right hand side of the curve. Right? One value will lie before 500, another value will lie after 500 because it is more than 500, and you will have to calculate the probability that a student will take between 420 and 570 hours to complete the program. So between 420 and 570, this entire area will be shaded. You will have to shade this entire area, and how you will have to calculate the probability, please see. First of all, between 420 and 500, next between 500 and 570. That is how you will have to solve it. So firstly, remember the formula, that is x minus mu upon standard deviation. Now x initially for this would be 420, mean will remain same upon 100. Now 420 minus 500 upon 100, that will be minus 80 by 100. Again solving this, you will get the value. You will get the value as equal to minus 0.80. Now remember, since the table is not having negative values, so you will have to take the absolute value, that is the modulus value, equals to 0.80. Now look into your tables and tell me what is the value of 0.80? 0.2881. Remember this value. So the probability between 420 and 500 is equal to 0.2881. Remember this thing. Next, the second part of this particular problem says that you have to find out the probability between 500 and 570. So the formula will remain same, that is x. Now x is 570, but mean will remain same, and so will be the value of standard deviation. Solving this, we will get the value as 70 by 100 equals to 0.70. Now what will be the table value of z at 0.7?
0.258.
0.258. Now this will be the value between 500 and 570, 0.258. Now what will we do? We will have to combine these values, 0.2881 plus 0.258. Now tell me what is the final answer?
0.5461.
0.5461 or 54.61 percentage. If you are asked to express this value in percentage, so it will be equal to 54.61%. Now take down the inference. The probability that a student, will take between 420 and 570 hours. Between 420 and 570 hours to complete the program. Is 0.2881 plus 0.258 equals to 0.5461. Now take down one more part. Find the probability that a student will take less than 600 hours. A student will take less than 600 hours to complete the program. Find the probability that a student will take less than 600 hours to complete the program. Now this part number 5, it says that you have to calculate the probability that a student will take less than 600 hours to complete the program. Now we will have to construct the curve for it. Remember, the central value will always be the mean value. Now 600. Obviously 600 will lie on the right hand side of the mean value, that is 500. Now less than 600. less than 600 will be the entire curve which is before this value of 600. Because anything less than 500 would also be included in this area, even if the value is 400, 300, 200, 100. So all those values, representing less than 600 will be represented by this entire curve, the entire shaded curve. Now first of all, we will have to apply this formula which says x minus mu upon standard deviation. Now the x is 600 over here, mean value will still be 500 and standard deviation will again be equal to 100. Solving this, you will get the value as 100 by 100 equals to 1. Now tell me what is the table value of normal distribution at 1?
0.3413.
That is 0.3413. So between these values 600 and 500, the value of the probability is 0.3413. And if you haven't forgotten, I just explained in the beginning that this entire area to the left hand side of the curve is always equal to 0.50. So what do? We add 0.50 to this value 0.3413 to derive the final answer. That is 0.8413, which can be expressed in percentage, that is 84.13%. Now take down the final interpretation. The probability that a student will take, less than 600 hours to complete the program is 0.3413 plus 0.5 is equal to 0.8413 or 84.13%. So these were some of the very crucial parts of normal distribution. Remember all these three distributions: binomial distribution, Poisson distribution and normal distribution, the indispensable portion of probability.